In this part of my review videos, I'm going to go over solving radical equations and also graphing them. All right, so number 14. First thing I want to do on all of these questions is to isolate my radical. So it doesn't matter if it's a square root, cube root, fourth root, whatever it is. I want to get my, if I have one of them, I want to isolate it, so get it by itself. So I'm going to move the 10 over with subtraction first to get the square root of 6x plus 1 equals 7. Now that I've isolated, I'm going to raise both sides to the second power, which will get rid of that square root. So 6x plus 1 equals 49. Move the 1 over with subtraction. You get 48, so x equals 8. Don't forget to check all of your solutions to make sure you don't have anything that's extraneous. So 6 times 8 plus 1 plus 10 is equal to 17. Let's see. That's 48 plus 1, which is 49. Square root of 49 is 7, plus 10 equals 17. All right, so x equals 8 works. Let's do b. Now, make sure when you get one of these on the final, you move, because it says minus, let's move this second one over to the other side with addition. So 3n plus 12 to the 1/4 power is equal to n plus 8 to the 1/4 power. All right, now I'm able to raise both sides to the 4th power to get rid of that 1/4 in the exponent, which is the same as the 4th root. I'll have students that won't do this step first of moving that n plus 8 over, and mathematically they just drop the 4th roots. They still get the right answer if they distribute the negative, but mathematically that's not okay. So I will take off a half a point if you do that. So make sure to move this over first. Okay, now we're going to raise into the 4th power. So you got 3n plus 12 equals n plus 8. So we have 2n equals -4, n equals -2. Let's check it. So I have 3 times -2 plus 12 to the 1/4 power minus -2 plus 8 to the 1/4 power equals 0. That's going to be -6 plus 12, which is 6 to the 1/4 power minus 6 to the 1/4 power. And the key thing here, guys, because of that index of 4, right, if you wrote this as the 4th root of 6 minus the 4th root of 6, right, you have to make sure that you have an even number, not even number, a positive number inside the radical because of an even index, and 6 is positive, so this works. So just be careful with that when you have an even index. All right, it's very similar to the last one. I'm going to move over that 5th root of 3x plus 3 to the other side first. Then I'm going to raise both sides to the 5th power. So I get 4x minus 17 equals 3x plus 3. So I get, move that over, you get x, add 17, you get 20. Checking this, the 5th root of 4 times 20 minus 17 minus the 5th root of 3 times 20 plus 3 equals 0. Now I care less about this because of that 5th root, which means I can have a negative inside. So it's not really as big a deal to check this. So that's 80 minus 17, that's going to be 63. 3 times 20 is 60, plus 3 is also 63, so that works. But again, the 5th root, that 5 being the index, is not as imperative to check. Okay, next one. This radical is already by itself, so I'm going to go ahead and square both sides right away. The key thing here, guys, is that I will be taking this x plus 1 and multiplying it by itself. So I get 7x plus 15 equals x squared plus 2x plus 1. If you don't know that, you should do x plus 1 multiplied by x plus 1 and do all the math, right? So now I'm going to set it equal to 0. So x squared, 2x minus 7x is minus 5x. 1 minus 15 is going to be minus 14. Factoring. So I get x minus 7, x plus 2. So x equals 7, or x equals -2. Now I'm going to check this. So I have the square root of 7 times 7 plus 15 equals 7 plus 1. So that's 49 plus 15 is 64. Does the square root of 64 equal 8? It does, so 7 works. Now I'm going to check negative 2. 7 times negative 2 plus 15 equals negative 2 plus 1. That's negative 14 plus 15 is 1. The square root of 1 equals negative 1. That does not work. The square root of 1 is not negative 1, so make sure you cross out that answer. Okay, our last solving one. I'm going to divide both sides by 2 to isolate this radical of the cube root. So I get x plus 4 to the 1/3 power equals 5. Then I'm going to cube both sides to get x plus 4 equals 125. So x equals 121. Again, you don't really need to check this one because of the fact that you have that odd index. But we have 121 plus 4 is 125. 125 to the 1/3 power is the cube root of 125, which is 5. And that works. Okay, let's move on to the graphing. All right, so hopefully you know the original points here for this parent function. This is a square root because of that index of 2 there. So I'm going to have 0, 0, 1, 1. The square root of 4 is 2, and the square root of 9 is 3. For my new function, I'm going to subtract 3, right? Remember, thinking the opposite for inside, and I'm going to add 5 to my y values. So that's negative 3, negative 2, positive 1, and 6. Adding 5. And I'm going to put those points on my grid. Negative 3, 5, anchor point. Negative 2, 6, 1, 7, and then 6, 8. I think I graphed 6, 8 wrong. Hold on. Hold up. My bad. I think I missed it. 6, 8. There we go. Okay. Now remember, for this square root function, we're only going one direction here, right? So I'm not moving to the left of negative 3. If I try to plug in something to the left of negative 3, I could not take the square root of a negative because after you add 3, it would still be a negative. So just be careful with that. So the x-intercept is not in the table, so you need to solve this, right? So you need to set this equal to 0. So I would subtract the 5 over. Square root of x plus 3 equals negative 5. Square both sides. X plus 3 equals 25. So x equals 22. That doesn't make any sense. Oh, I know why, Douglas. My bad. When you move this over, I apologize. When you move this over and get here, there is no way for that square root of x plus 3 to ever equal a negative 5, right? So you have no x-intercept. If you got the 22 and plugged it back in, you would see it's extraneous. Okay. So let's go ahead and find the y-intercept. This one we can find. Plug in 0 for x, which 0 plus 3 is just 3, so the y-intercept is 5 plus the square root of 3. Oh gosh, Douglas, man, I'm making so many errors today, I apologize. 0, comma, 5 plus the square root of 3. Again, if you want to use a decimal, if you have a calculator, that's fine. All right, domain. My lowest x value is negative 3. I can plug in any numbers to the right of that. My lowest y value is 5, and I'll keep going up forever. So that is it for this square root. All right, let's do the cube root. The cube root function has these for the original points. All right, I'm moving this not at all left or right, right? See how there's nothing inside with this x. I am going to do the opposite of my y values for that reflection over the x-axis and subtract 3. So my new points are going to be the same x values, but the opposite of negative 2 is 2, minus 3 is negative 1. The opposite of negative 1 is 1, minus 3 is negative 2. This one's negative 3, negative 4, and negative 5. Okay, so plotting these points. going to look a little different than the original because of that reflection. But you can see the difference with this cube root. We're going both directions forever. So it makes the domain and range really easy. The domain and range is going to be all real numbers. There we go. Okay. And then for the y-intercept is actually in the table, 0, -3. The x-intercept I can solve for, setting this equal to 0. So I have 3 equals the opposite of the cube root of x. So -3 equals the cube root of x. So I'm going to cube both sides. -3 cubed is -27. So my x-intercept is -27, 0. All right, let's do 2 more graphing. Another cube root, so put those same original points in there. Okay, I'm going to this time have to move 1 to the left and then 2 up. So -9, -2, -1, 0, 7. Adding 2. All right, so plotting these new points. All right, so here is my curve. Did I do it again? Gosh, I did it again. Man. Whew. Comments on this one are going to be tough. 7, 4. There we go. All right. So domain and range. All real numbers again. Let's see. Oh, nice. My x-intercept is in the table. Same with my y-intercept. That worked out nicely. All right, last one. Back to square root. So I have 0, 1, 4, 9. 0, 1, 2, 3. Okay, I am doing adding 5 and then doing the opposite of it for that reflection, plus 4. So adding 5. Okay, and then the opposite of 0, plus 4, opposite of 1, plus 4, opposite of 2, plus 4, opposite of 3, plus 4. So here we go. 5, 4, 6, 3, 9, 2, and then 14, 1 is going to be somewhere over here. So again, tricky thing here is to make sure that you're only going one direction for this square root. There we go. Okay, so my domain, my lowest y value is 5. And the range is a little tricky. I'm actually going down forever. So -infinity, 4 is my highest y value. I'm not going to have a y-intercept because I'm not going to keep going that way, so none. And I will get an x-intercept at some point. So 0 equals the opposite of square root of x minus 5 plus 4. So move that 4 over to -4. Make it the opposite, you get positive 4. Square both sides, you get 16. And then add 5, you get 21. So 21, 0 is when you would hit the x-axis. All right, guys, that's it for this part. My next videos will be focused on Unit 8, the exponential and logarithmic unit.